Yes, ma'am. So we are here to present you the 32 generic talk series on sustainable innovation in payment materials and design. So on behalf of the Department of Civil Engineering, I like to thank our management for providing this opportunity. And we are here today, Mr. Jegan Bharath Kumar, scientist, National Transportation Planning Research Center, Trivandrum. So good morning, sir. Now I like to call our Dr. Andal, Head of Department Civil Engineering, to introduce about the chief guest. Ma'am.
Good morning to one and all present here. Thank you, Arun Pratap sir. On behalf of our management, our chairman sir, honorable chairman sir, respected vice chairman sir, respected principal sir, advisors sirs, and dean sirs, HODs, faculty members, students. It gives me immense pleasure to extend a warm and cordial welcome to this special meeting on sustainable innovations in payment materials and design. We are truly privileged to welcome our chief guest, Dr. A. Jegan Bharath Kumar, scientist at the National Transportation Planning and Research Center, NATPAC, Trivandrum. Sir, your presence here adds immense pleasure to our program, and we are deeply grateful to your time and participation.
Thank you.
Now, it is indeed a great honor and privilege to introduce to this august gathering our distinguished chief guest, Dr. A. Jegan Bharath Kumar, an accomplished scientist at the National Transportation Planning and Research Center, Kerala State Council for Science and Technology and Environment, Government of Kerala. Dr. Jegan Bharath Kumar is a dynamic researcher and technocrat in the field of transportation engineering with rich and diverse experience spanning over 15 years in pavement design, traffic studies, road safety, and transportation planning. He is currently serving in the Traffic Engineering and Safety Division of NATPAC, where he is actively involved in a wide spectrum of research and consultancy projects that address some of the most pressing challenges in road infrastructure and mobility management. So, Dr. Bharath Kumar holds a bachelor's degree in civil engineering from the Government College of Engineering, E Road, and master's degree in transportation engineering from the College of Engineering, India, Anna University, and he is presently pursuing his PhD at National Institute of Technology, Tiruchirappalli, where his research focuses on experimental investigation of moisture in asphalt mixes under the guidance of Dr. V. Sunita, Associate Professor. So before joining NATPAC, Dr. Bharath Kumar gained valuable industry experience working with the leading engineering firms such as CCCL, then Consulting Engineers Group Limited Jaipur, Architechno Consultants Bhubaneswar, where he served as Assistant Manager Transportation. His professional journey in both industry and research has equipped him with a unique blend of technical expertise and applied field experience. At NATPAC, Dr. Bharath Kumar has played a key role in a wide array of national and state level projects. Some of his noteworthy projects include experimental investigation of porous asphalt, development of mobility plans for Varkala and Attinkal towns, feasibility study for sea cruise service between Kovalam and Kanyakumari, integrated urban regeneration and water transport system for Cochin, and several kill highway DPR, that is detailed project report and road safety audit projects across Kerala. He has also been deeply involved in projects related to climate change and transport, contributing as nodal officer for the Directorate of Environment and Climate Change, Government of Kerala, in preparing state action plan on climate change. Dr. Bharath Kumar has an impressive list of publications in reputed international journals. He is a life member of several esteemed professional organizations, including Indian Road Congress, Institute of Urban Transport, in the Indian Geotechnical Society, American Society for Civil Engineers. In addition to his research accomplishments, Dr. Bharath Kumar is also an active academic contributor and mentor. He has guided numerous postgraduate and undergraduate theses and internship, helping a new generation of civil engineers. He has delivered several guest lectures and faculty development sessions. His professional experience, matched by his commitment to road safety awareness and community outreach. He has organized and participated in multiple training and awareness programs. Dr. Bharath Kumar is also an active technical reviewer for several leading international journals, and in recognition of his contribution to research, has been recipient of UGC postgraduate scholarship for professional courses, and has continually contributed to policy level documents, including the Kerala State Action Plan on Climate Change. So, with his vast experience and dedication to improving India's transportation systems, Dr. A. Bharath Kumar stands a role model for aspiring civil and transportation engineers across the country. Sir, we are indeed privileged and honored to have you as our chief guest today. On behalf of everyone present here, we extend a warm and respectful welcome and look forward to your inspiring address. Sir, please.
Thank you, madam. Thank you for your biodata and vast laying out my personal integrities. So in this lecture, I would like to thank principal for inviting me, and also HOD Madam Dr. Andal, and also my dear friend Sri Mr. Arun Pradap. So let me share my screen. I hope my screen is visible to you.
Yes, yes, yes.
So today's topic for the discussion is on sustainable innovation in payment materials and design. So before going into the topic, I would like to introduce about my institution to you. So NATPAC. NATPAC is a National Transportation Planning and Research Center. It is an R&D institution established by the government of Kerala. So in our institution, we undergo research and also the need-based study for helping the government or helping the aligned departments in the area of traffic engineering, highway design, road safety, inland water transport, and tourism and planning, and also geotechnical and intelligent transport systems. So we have our head office in Trivandrum and our regional office located at Kozhikode and also in Ernakulam. So these are the major facilities that we have in our research center. So we have a wide number of laboratory facilities for both for the highway materials and also for the geotechnical investigation and also for the bituminous mixtures. So few of the facilities are available, sir. Few of them are like related to the payment performance tests. That is, one is the mist and another is the rut resistance that used to evaluate the deformation that is caused due to the wheel repetition that is observed over the surface of the pavement. And the next one is the mist, which is the simulation equipment which used to simulate the moisture and also used to simulate the pressure that is occur during the frequent movement of the traffic. So here we could able to test the different scenarios with respect to the temperature, with respect to the pressure that is generated from the movement of the vehicles. And another one is the next one is the viscometer, where we can find the viscosity of the bitumen, and we have the equipments that to evaluate the functional and the structural evaluation of the payment. That is the BBD, that is the Bengal band beam, and also we have a triaxle for in order to find the compaction of the soil as well. And we also have few of the traffic equipments, that is the V box and also the turtle, from which we could able to find the 24 traffic movement in the any of the road category, and also the uh, running speed and also the travel time of the vehicle that can be evaluated using the video e-box. So we also provide trainings to the students and also to the drivers and also for the corporates with respect to the road safety education. So road safety education has been given to in all levels, like starting from the schools, starting from the corporates, and also among the police officials in order to provide them awareness on the road safety. So before going to this one, actually, I also request that there is an opportunity for the students as well from our institute. Like I would also invite the students who are interested in working in varied number of civil engineering, such as highway, geotechnical, hydrology. So we also used to provide guidance and also observe the students in the form of internship as well. So it can be ranges from the masters in civil engineering and also for the bachelor in civil engineering. So for the further information, you may please visit our website natpac.kerala.gov.in. So coming to this today's topic, so let me start with the payment. So let us have a basic knowledge or the basic understanding of the payment. Payment is nothing but the surface that could withstand the traffic load that can playing over the payment surface. So basically, the payment is laid over the subgrade. So beneath we have a granular materials in place of which can be act as a which can be act as a drainage layer as well as the strength layer. So basically, it have a different structural elements in the form of layers, including the shoulders, which is paved and also which cannot be, which is also absorbed unpaved as well. So coming to the functions of the payment. So basically, the function of the payment is to exactly to distribute the traffic load that is playing over the row, loading over the subgrade. So it gives provide the access between the 2 points, whether between the 2 points under every weather condition. So the payment should function, should provide a better drainage system, should provide a safer and smooth and comfortable ride for the road users, and also it should withstand at all climatic conditions. So the payment has to be reasonable economic in all aspects as well. So what is the requirement of the payment? So the requirement of the payment with respect to it, it is we can able to empathize on the sufficient of the thickness. So as we have seen, like there are various number of thickness in based upon various layers observed in the payment surfaces. There should be a sufficient thickness based upon the traffic that is expected over the road surfaces, and it should be the payment should be designed in such a way that it should withstand its design life as well. So there are payment material should be impervious to the surfaces that it should withstand the surface of the surfaces against the heavy loads and also against the any of the environmental adverse environment that is occurring over the course of the time. So the payment should be very smooth enough to provide a comfort both to the road users and also for the vehicle users as well. So why do we need payment? So the payment is to provide the access to all the vehicle users and also to the pedestrian. So it forms the connectivity between the 2 points. And in India, we are most of the roads are flexible payments that is used with that is constructed using the bitumen. So here the as far as India is concerned, we are handling about 80%, 60% of the freight transport and also 80% of the passenger transport. So in order to meet the needs, the construction of the payment is important, and what is the technology we are using for the construction is also important, and also the materials what we are using for the construction of the payment also is essential, and it is very vital. So coming to the payment cross section, so this is the typical payment cross section. Here we have bituminous layer and as well as the granular layer. So here the bitumen layer. So first we have the subgrade. Over it we have a subbase. So here the subbase is act as a drainage layer, which is the thickness of the subbase varies from 100 mm to 300 mm. So over that we have a base course, which is act as a strengthened layer. So here the base course ranges from 100 to 300 mm. So the most vital and the layers is the bituminous layer, which is the most costly as compared to the construction of the other layers. So here the bituminous surfaces can be segregated into binder cores and as well as the surface cores. The surface cores varies from 25 to 50 mm, while the binder cores varies from 50 to 100 mm. So as we mentioned, so these are the essential functions of each of the layer. So starting from the surface to the binder cores to the base cores and the subbase layer. So here, as we see, so the most important and the most vital that receives the maximum interaction from the repetition of the vehicle load is the bituminous pavement surfaces. That is the surface and the binder courses. So based upon the particle size, the bituminous mixes can be divided into four. That is the dense graded asphalt mix, open graded, gap graded, and fine graded. So here in most of the highway constructions, we are using the dense graded asphalt mix both for the NH and also the SH and mostly for the all the village roads. So the other are the very specialized uh, bituminous surfaces where it can be applied based upon the availability and based upon the conditions. So here, as far as the dense graded asphalt mix is concerned, we can say it is a well-graded distribution of the aggregate gradation, starting from the mostly of nominal aggregate size of 19 mm, and it is used in the base layer, intermediate, and also the surface layer. And here next is the open graded asphalt mix. There, in the case of dense graded mix, we have an average air voids. So air voids is a vital functions in the Marshall mix design. So as far as the dense graded mix is concerned, it varies from 3 to 5 percentage, while for the open graded, it have to be a minimum of 18 percentage to the maximum, so that it is a very specialized asphalt mix where you can have a storage of underground storage of surface water as well. So here in most of the high rainy conditions, regions of the highly rain condition, the open graded mix will be applicable and are used widely. So coming to the gap graded, it is a very high coarse aggregate and it also has a very high bitumen content as well. And we can say it is economically it is higher as compared to the other mix. But as far as the durability is concerned, it provides a very good durability as compared to the other mix. As far as the fine graded mix is concerned, has a very low air voids, thereby it gives a very good strength. And it is a combination of low air voids and the high binder content as far as the gap graded and the dense graded mix is concerned. So here we could see the pictorial representation of each of the layers. So here we can see the aggregate structure or the aggregate gradation, how the each mixes bear. So here in the dense graded, we can see there is a combinations of fine and the coarse aggregate, and here we could say like there is a almost an equal combination of both the types of the aggregates. Whereas in the open graded, we could see a number of gaps that we call as an air voids. So that the water from the surface of the pavements can come down and can be absorbed. It is used as a harvesting, rainwater harvesting. So coming to the gap graded, it has a very good cohesion and adhesion between the binder and the aggregate. That's why it provide a better durability. So coming to the paving the way to the sustainable future. So before starting to the sustainability, we can understand what is sustainability. So sustainability can be mentioned as it is the need of the present without compromising the future generation. So here it is always mentioned as triple bottom line components. There are the components such as economic, environmental, and social aspects will come into the picture. So as far as the payment is concerned, it should be economic and it should be resistant to the environment, and it should meet the social expectation as well. So coming to the role of the payments in sustainability, so payment, what your construction should have an energy consumption. So as we all know that during the construction of the payment, we are consuming more number of energy, because due to the burning of bitumen or due to the mixing of the aggregates, we have to use lot number of fuels. So because of the combustion of the fuels, we are emitting more number of CHC gases. So that is the main aspect for the during the that we are facing that during the construction of the pavement. So habitation loss due to the construction of the pavement, your deforestation happens, and that is also have to be taken into account, whether as it impacts the social impact as well. So due to the construction, we have the loss or change in the water quality, air quality, and also because of there is also a economic development as well. So these are the key roles, or these are the key factors that is responsible or that take part in the sustainability in case of the payment construction. So how the sustainability can be measured? So the sustainability can be measured based upon the performance. So how, as far as the payment is concerned, how the performance is assessed in the case of life cycle cost analysis that we called as LCCA. So here from the collection of materials to the construction of the payment to the maintenance of the payment and to the end life of the payment. So that cycle the cost involved in this cycle that we mention as the life cycle cost. So it has to be measured in terms of environment, in terms of economic, and also in terms of the social impact as well. So based upon this, the rating can be done. So based upon the rating, so which type of the payment or in which region, which type of payment is applicable, and what is the thickness we have to use, and what is the materials we have to use. Everything is based upon this measurement. So based upon this, we can measure the sustainability of the payment as well. So coming to the sustainability innovation, we can categorize into through three. That is, one is the sustainable materials, another is the sustainable techniques, and another is the sustainable methods. So here the sustainable materials is concerned, like we are going to there are many sustainable materials that is available as of now during the payment construction, and that also been used for the payment construction, and a lot of research has been carrying out how the usage of the marginal materials or the additional materials for the road construction or the payment construction, and its performance has been evaluating periodically in order to find how it performing over the years or over the design period of the payment. So here we are going to empathize on the three categories, that is the recycled aggregates, biobitumen, and the high modulus asphalt. So coming to the sustainable techniques, there are various techniques, and we are going to discuss few of the techniques that is applicable or that is carrying out in our country. And also coming to the methods, so what are the methods we can adopt in order to have a sustainable payment with respect to the cost, with respect to the economy, and also with respect to the social aspects as well. So coming to the sustainable material, so the first one we are going to empathize on the wrap material. So wrap is nothing but the reclaimed asphalt pavement. So here we can also say the recycling of the pavement. So basically, the thing is like if it is mainly used for the rehabilitation of the existing pavement. So for the rehabilitation of the existing pavement, what we usually used to do is the existing pavement surfaces will be scarified. That is, the bituminous surface can be scarified and it can be mixed with the new material, that is the virgin material. So in order to avoid or in order to reduce the virgin material, we are using the already existing material and we are mixing with the virgin material. So that we call as the wrap material. So this technology or this material will help you to reduce the virgin material, because there is a wide shortage of the materials. That's why this technology has been considered as one of the vital in recent days. So here, as far as the wrap is concerned, so this is the process involved. So here, as far as the damage of the pavement is concerned, so due to the frequent repetition of the wheel loads, we could observe various number of surface defects in the pavement. So it ranges from the cracking. There are various surface defects such as cracking, that we observe that the cracks that is observed on the surface of the pavement, and the rutting, that is the deformation we could observe, the potholes, and also the raveling. Raveling is refers to the disintegration of the fine particles. So it depends upon, so a wrap cannot be applicable to the all, but it depends upon the structural integrity of the existing pavement and also the surface defects that is available on the existing. So based upon this criteria, we can able to implement this asphalt in for the rehabilitation purpose as well. So initially we have to observe what type of damage it is available on the pavement surface. So based upon that, the milling can be done. Milling is nothing but the scarifying the bituminous surfaces that is observed on the entire pavement structures. So after that, the milling material will be segregated based upon their sizes, and it can be recycled with the virgin material based upon the different sizes, and after that the material can be treated and it can be laid over the existing pavement. So main advantage that we can see for the wrap material is reduces the need for the virgin aggregates, and also it reduces the energy consumption as well as the cost, and also decreases the emission in the production as well. So these are the benefits that we can able to observe from the wrap material. So here we could see the process. So this is the process of the wrap. So here we have a different categories of the machinery for the entire process. So here we can see. So before going for the milling, we have to preheat the existing. So that we called as a hot mix process. Whether preheating is not done, then it can be called as a cold mix process, cold mix process. So in the premix, it is the top surface is being heated. Then after that, it is clarified and it is sent to the roller. The roller will mix with the virgin aggregate, and at site itself it can be paved and it can be laid again. So it can be done at site, and also it can be done at the production unit as well. So these are the two methods that can be followed for the wrap. So here we could see, in order to understand, sorry. So this is the process involved in the wrap. So here they have segregated or scarified the material, and they are mixing at the batch plant. And it is been laid over it. So in the batch plant, the wrap material and the virgin material has been mixed, and it is the process you can observe. It is done at the site. So this is the mixer, and it mixes the virgin material as well as the wrap material, and it is been laid. So next one, moving to the next one, this the bio-based asphalt. So the bio-based asphalt is nothing but we are using the alternative or eco-friendly material, which can be in the form of any renewable resources such as agriculture waste or linen or a biomass. So here we could able to reduce the carbon emission up to 70% in case of bio-based asphalt. So here the as it is also considered as the one of the sustainable resource uses. And here in India also we have used bio-based asphalt. So here in India, like in Nagpur Mandsaur bypass on NH44, that is considered as the India's first national highway bio-bitumen. So there the sustainable alternative material has been used, and it was used for around, I think, like 1 kilometer long. And here it uses 50% has been replaced with the bio-bitumen. So this provides it has been like yet it is the performance of the asphalt has to be evaluated in the field, but there are various laboratory investigation has been done, and it is found to be performing good. So coming to the sustainable techniques, so there are various sustainable techniques that is available for the pavement construction. The first one is the warm mix asphalt. So usually the hot mix asphalt is we are widely using. So here for the HMA, that is the hot mix asphalt, we are using like we used to have a heating temperature or the mixing temperature of the aggregate with the bitumen that it can consume about 150 degrees Celsius to 160 degrees Celsius, whereas in the warm mix asphalt, the mixing temperature of the bitumen as well as the aggregate ranges from the 100 to 130 degrees Celsius. So here we could see about 30% or like 10 to 30% reduction in the production temperature. So that reduction makes a lot of differences in case of the environmental aspect and also with respect to the economy as well. So here the warm mix asphalt is one of the main methods that we can consider, and also like for the for the varying tropical climate also it can be used. So next one is the porous asphalt mix. Here this is also called as a open graded mix, where we have to maintain air voids, that is the air voids of greater than 18 percentage. So thereby it can able to absorb the water. So water cannot be drained, but we are allowing the water to not to drain. It is sending it into the pavement structure, and thereby it provides a drainage for the surface. And generally this pavement is high porous, and it is not suitable for the high traffic condition, whereas it is only suitable for the low volume roads, that is for the parking lots, and also for the where the traffic is very low. So it consists of open graded mix followed by the other components of the pavement as well. So here we could see a structure of the porous asphalt. So here the porous asphalt. So adjacent to that, we will be constructing a aggregate layer. So in order to collect the water over it. So beneath that we have a stabilizing course or a stone reservoir in order to store the water. So it is act as a like water harvesting. So mostly in the foreign countries, like they are using this type of payment for the where the rainfall is very huge in order to maintain the water table of the water table. So it is a very important or very useful asphalt mix that can be used for the purposes. And here, as far as the porous asphalt is concerned, the maintenance is quite different and quite difficult as far as the other hot mix, other dense graded mix is concerned. Here the maintenance is very vital, as we are maintaining a very vast air voids, that is 18%. Some sort of fine particles or the waste particles are able to occupy those voids. So maintaining that air voids is very difficult and very essential in order to have a porous asphalt. So we can see few of the advantages. So we can see this is the pavement structure. So that traditionally we will have a dense surface. Beneath that we have a subbase and the GSB, that is a drainage layer. Whereas in the that is the OGFC or the porous asphalt, we have a permeable subbase that can be used for the harvesting of the water. Here also we have in Jaipur, they have implemented or they have constructed the porous asphalt during 2012. But the performance or the how it perform, that performance is yet to arrive. So coming stone matrix asphalt. So this is the very high rut resistant bituminous concrete or bituminous course, we can say. So here we are using very high bitumen content as well as the very high number of coarse aggregate as well as the fine aggregate. So here we could say it is this can withstand a very high or a heavy traffic condition. So the based upon that, the road construction cost for the SMA is also very costly. So here the SMA is mainly for in the junctions they are using, as it is very stiff and it can withstand a heavy traffic condition as well. So economically it is quite high, and it provides a very good rut resistance as compared to the other bituminous mixtures, and it also provides a stability and a binder rich mortar to provide the durability of the pavement as compared to the other bituminous mixtures. So here, as far as an Indian scenario is concerned, we have a Indian Road Congress guidelines for the construction or the selection of materials and the type of materials they have to use for the stone mastic asphalt. So in India, it was started using it since 2009, and we have IRC code of IRC SP 79/2023, the latest one that guide us to design the SMA. So this is the next sustainable method that is available, that is the full depth reclamation, and this is the recently or widely used one of the rehabilitation strategy or the rehabilitation technique for the pavement. So here what it is similar, like we can say it is also one of the method for the recycling, that is as compared to the wrap. So in the wrap only we are scarifying the bituminous surfaces, but here in the full depth reclamation we can we can use both the granular and also the bituminous. We will scarify both the granular and also the bituminous surfaces, and we'll be mixing it, and it can be we can be laid as a thick or bound hardened base course as a new pavement. Over that we can lay a new bituminous pavement. So here, like, we are not dismantling the entire pavement. So in case of in case of not dismantling the entire pavement, we are just using the part of the bituminous and also the non-granular layer for the construction of the new pavement surfaces. So here it includes four steps, that is the excavating, pulverizing, blending with binder and water, and the compaction as well, and laying the surface. So it also, the same as the wrap, it also has a series of machinery. So it can be done at site, and also it can be done at the plant as well. So here we could see the full depth, it will scarify, and it will scarify both the bituminous and the non-granular, and the additive can be added in order to provide the better durability of the pavement. So this also, the FDR that we called as a FDR, that is full depth reclamation, it can't be applied at all circumstances, but based upon the site constraint and also the material and also the structural evaluation or the structural integrity of the existing pavement, this method can be adopted. These are the few advantages or for the FDR method. So here the minimum requirement of the new materials can be considered here. So it is considered as one of the green technology, and it is less susceptible to the moisture intrusion as well. And here, if this can be applied when your subgrade strength is good enough to have a pavement construction. So this is the machinery that is involved for the full depth reclamation. Here you can see the reclamation machine is there. So using that, they will be scarify the surfaces, and it is brought, and after that it is been treated with the virgin material. Then after that it will be laid over, and after that the rolling process can be done. So these are the there is no full-fledged guidelines is available, but rather, like, still the performance has to be evaluated for this technology as far as our country is concerned. So the few of the available guidelines for the design of RAP, that is for the FDR is IRCSP 86, that is Indian Road Congress Special Publication 89, and also we have for the low volume roads proposed by the Rural Road Authority. So here we can see how it has been implemented. So the wrap material is brought to the plant, and it is being treated in the site. So this is the exact process how the FDR is constructed. So it is milling the bituminous surface to a certain depth. And after that, the admixture can be used for stabilizing the material. So that can be laid over the existing pavement surfaces. Then after that, the compaction is done so that the new pavement can be constructed. Sorry. So next one is the perpetual payment. So perpetual payment is nothing but the long-lasting payment. So it gives a very good structural integrity, and also in terms of construction, and also in terms of the maintenance as well. So here, as far as the perpetual payment is concerned, as far as the layers is concerned, it have a that is the high designed bituminous layer. Beneath that, it has an intermediate layer for the for withstanding the traffic load, and it also has a wearing surface that is specially designed to restrict the fat that is cracking and also the rutting, that is the deformation that is caused to the repeated wheel repetitions. So coming to the advantages of the perpetual payment, so it has like it can reduce the life cycle cost of the payment is less as compared to the other conventional payment. So and here we can see the rehabilitation or the maintenance and the regular maintenance and the routine maintenance for the perpetual payment is very less as compared to the conventional payment. So these are the here we could see a cross section of the perpetual payment. So we have a very good strong that is subgrade, that is strong subgrade over it. We have a high modulus or rut resisted bituminous surfaces with the high bitumen grade that is used in case of the perpetual payment. So it says that it can last more than 30 years as far as the perpetual payment is concerned. So the another one technology is the intelligent compaction. So as far as we know, that compaction for for any road construction, maybe a bituminous road or the concrete road, the compaction is very essential. So the over compaction or the less compaction will lead to the affect the payment life. So here, what they have adopted is like intelligent compaction in the sense like so when the compaction is done at each location, we can able to find what is the compaction it is done through the various sensors, so that like we can able to observe so where the compaction is lacking and where the over compaction has been done. So it is compaction is done usually through the number of passes. So while moving like while applying the passes over the bituminous surfaces, we can able to find and we can able to find where the compaction is less and compaction is more. So we have a series of sensors. So in this system only it works. So here like usually they used to provide the location like geotag. They can give the geotag like in which latitude and longitude like the compaction is lacking. So based upon that we can able to modify or we can able to do the compaction process more effectively, so that like it adds durability to the payment structure as well. So here we can see like using the DGPS equipment, we can able to locate the location. So already this mission have a inbuilt DGPS as well, so that it can locate like where the what is the intensity of the compaction. It has been given for the entire payment structure, and with respect to the lat long, we can able to monitor it. So the next one is the advanced mix design. So here in India, we are using the Marshall mix design. So which is mainly based upon the density parameters. So based that works mainly on the density parameters with respect to the mainly on the air voids. So what is the air voids? But rather the advanced mix design that is being followed in many of the foreign countries and European countries is the super pay mix design. So here in the super pay mix design, it is mainly on the works on the both the density parameters and as well as the performance parameters also. So here they are considering both like the density and as well as the performance. While the Marshall mix design that we are following, it is more emphasized on the density parameters alone. So here by adopting the advanced mix design, then we can able to provide a everlasting and the performance based like some performance based payments, so that it can serve the entire service life of the payment. So here it considers like super pay system, that is the design system itself. It considers traffic and as well as the climatic condition during the design and also the performance evaluation as well. So here this is the special. This is the equipment where you can design the bituminous mixtures based upon the super pay. And here here we can able to find the taken into consideration the orientation of the compaction as well. Whereas in the Marshall mix design, we are not, because it is a very stable and under the stable condition only we are giving the compaction, while here we can able to provide the orientation also when the compaction is applied. So that part also has been taken into consideration. as far as the super pave is concerned. So advanced mix design, it is considered as one of the advanced mix design. Here we have the processing like selection of bitumen and aggregate materials and developing the aggregate blend that it has a requirements. Super pave have a requirements, so that requirements has to be met in order to have a better payment design. So coming to the sustainable methods, so there are few sustainable methods that is available. So due to the advancement in the technology, the same advancement technology has been applied for the payment construction as well. So here, few of the sensors or the advanced technologies such as sensors or IoT or modern data analytics can be used in order to enhance or in order to monitor the payment performance over the period of time and over the period of the weather condition as well. So this real time data will provide us to understand how the payment life like payment system works or how it is improved. For example, if you are adapting or we are taking any marginal material, so how the marginal material add to the performance of the payment, that can be monitor in like over the years, or that can be done using the smart payment systems. So for example, this iWatch Road, this is one of the payment monitoring system that has been under process for the detection of the potholes. So here it has been developed by NICER. So what basically detects the pothole and it gives the geotag where it is located and where it is located. So after that, like some remedial measures has to be done in order to in order to overcome that pothole. So after that, how the payment performing after giving routine maintenance, that can also be monitored using it. And they are also using a integrated road planning using the smart payment systems in Chandigarh, that also in the very initial stage. As far as these are the two things that in India it is available as far as the payment smart payment systems is concerned. So here we could able to see a physical twin and a digital twin. So how the payment smart payment system is has been carried out. So here using the sensors. So this is like in foreign countries, like this has been carrying out. So for the evaluation of the performance of the payment before construction, so they have a test track and all. So from in the test track, they used to maintain the smart payment system and observe each and every day and every season, and based upon the different smart materials also, they used to examine or they used to monitor the performance of the payment with respect to heavy load repetitions with weather conditions and all other aspect as well. So based upon that, they will modify the payment design in order to attain a durable payment system. So these are the this is the that is in Chandigarh. They are also doing a GIS based and AI based for the road development, and Surat also they are also like doing a planning for the AI driven monitoring system for the payment. So like using the CCTV cameras footages and using the images, they are planning to monitor the performance of the payment or performance of the surface defect that is occurring the payment, and what remedy measures, and after the application of the remedy measures, how the payment is performing, that also it's been monitoring. So this system right now they are planning for Chandigarh and Surat. So coming to the payment life cycle. So as far as the payment life cycle is concerned, we have a five components in the life cycle, that is from the cradle to the grave. So from the starting of the construction of the payment to the end life of the payment. So that has economic, it has a energy requirement, and it has also a social impact over it. So here during the collection of the material, so whether the what material can be collected, whether the virgin material or we can use the already used material or the construction waste material, that also should be considered in order to have a sustainable payment life cycle. So we have to adopt the construction. The construction type also it varies as with respect to the region as well. So that also have to be that also has to be taken into consideration, and for which traffic or which subgrade strength, what type of mix has to be used, that also has to be ensured in order to have a better durable payment, and the routine maintenance and also the periodic maintenance of the payment has to be done at equal intervals so that the payment will serve the rest of the design life. So that is also a very important consideration. So, and we are investing a lot of money for the payment construction, for the highway construction or any road construction. So these parameters have to be taken into consideration, and these parameters or these components has to be monitored at every interval so that the payment can be durable and with respect to the varying traffic conditions and also the weather condition as well. So there are few that is LCA, that is light cost tools is available. But here it is with respect to the foreign countries, there are also very these are the tools that is available in the away from India. So this gives a better understanding how the payment life cycle happens. So we could able to understand how the payment life cycle is can be adopted or cannot be taken into consideration, because in order to have a sustainable environment or sustainable payment structure, these tools are very essential. These are the few tools that can be used. Fewer academic tools and fewer implementation to industry developed tools also. So here in these tools, like a lot of information will be required in order to find the payment LCA payment life cycle understanding. So that sort of information will be required. So that much empathize they are providing in order to have a sustainable payment construction. So that sort of we are also adopting. So because like we are also adopting in order to have a better road infrastructure. So coming to the carbon footprint. So as far as the payment construction is concerned, so during the construction itself, we are emitting a lot of CHG, that is greenhouse gases, that is released. So already we have discussed like how to reduce the temperature. So because of reducing the temperature, we can able to uh, be able to avoid few of the greenhouses gases that is polluting the atmosphere. So these are the main 6 CHG emission that is occurring during the construction of the payment or construction of the highway. So that is CO2, CH4, N2O, HFC, and fluorocarbons as well. So coming to the carbon footprint, so at each and every step of the payment construction, we are consuming a lot of energy, and we are also like emitting lot of greenhouse gases as well. So starting from like mixing, that is the during the collection of the raw materials, during the production of the raw materials, and during the mixing of the raw materials, that is mixing process such as mixing the bitumen aggregate, and also after the mixing batch is sent to the site. So during the transportation also we are consuming few energy. So everything like it constitute to the carbon footprint. So in order to reduce the carbon footprint, like we have to adopt a specific technology or a specific material that is suitable for the exact for the payment construction and also for the payment rehabilitation measures as well. So thank you for your patience. So if you have any doubts, you may please ask. Thank you.
Thank you, Jegan. So, do you have any case studies?
Case studies, actually, as of part of this, I hasn't kept any case studies, but case studies are available. Like I have already mentioned, like as far as the biobitumen is concerned, for the advanced technology, we don't have any case studies because it has been implemented very recently. So the performance of the payment has to be evaluated. So it will take few years to monitor the performance, how it works. So after that, we can able to understand how the new technology in our climatic condition are in India, how it works. But
Okay,
rather
so
like
what are
old technology is also available. Like as far as the marginal materials is concerned, you can plastic roads and also the crumb rubber roads. Everything is available. But I have considered this only for the reason that is gaining more popularity very recently.
Sir, I
okay?
have
What
one
are the
question,
ongoing
sir.
projects? Yes. What
Yes,
are the
sir, I
ongoing
have.
projects at NATPAC?
As far as our NATPAC is concerned, we have we are doing like few of the DPRs, that is for the detailed project report for the coastal highway, and we are as far as the research work is concerned, we are doing working on the interaction of moisture in the pavement surfaces. We are working on the overloading. We are working on the marginal material on the subgrade, and we are working on the ITS, that is emergency vehicle route rationalization and all.
Okay. Okay, Jegan. Thank you, Jegan. Any other questions?
Sir, I have one question, sir.
Yes.
Sir,
Yes,
since
ma'am.
Kerala is susceptible to heavy rainfall, sir, any special additive materials are you adding to improve the strength of the pavement, sir?
Madam, actually, we are working on the FDR technology. So FDR technology is one of the widely used technology that we are adopting. So we have like few of the roads in our state, like we have used that FDR technology. So it is like around 20, 30, 25 to 30 kilometers has been proposed for it, and few of the road has been proposed for the FDR technology as well. So as far as the rain is concerned, we are working on that, but how the moisture intrusion causes the delay in the surface defects of the payments, that also we are doing the research over it. But as far as the research is concerned, like laboratory research we are going, so we are planning for some implementation as well. So hope in the future we can able to give more productive performance results of it.
Thank you, sir.
Sir, good morning, sir.
Good morning, ma'am.
Dr. Hemamati, sir. Sir, I have a doubt. So, in Tamil Nadu, see, I have seen in many places they are doing with a rigid payment. So, how does this rigid
Mm.
payment contribute to the sustainability, sir? That too, particularly here, maybe I'm not sure whether you are known to it. Like we have that Ennur. So the been done only as rigid payment with very large concrete slabs and all, sir. How does it contribute to the sustainability part, sir?
Yeah, as far as the
And
sustainable is yes, ma'am.
sir, also, how is it possible for heavy? I mean, they are laying concrete roads and all. Will it be able to carry that heavy load, that is the trailers which is passing by and all those things, sir? And what will
Mm-mm.
be the lifespan of those type of payments, sir?
Ma'am, as far as the bituminous payment and concrete payment is concerned, basically it is understood like concrete gives the more durability as compared to that. But rather, like the maintenance of bituminous and the concrete is different. Like it is for the bituminous, it is for maintenance is very like it is easy, and whereas for the concrete it is it is somewhat difficult. For example, it is everything is like based upon the panels. Like if one panel is get breaking, like replacing and repairing of it, it requires more time, and it is so what to say, it is so critical. So in that way it is, and also as you have mentioned, the heavy loads it can sustain, like payment it can sustain the heavy loads as well. So there is no adverse opinion about it. But as far as it has a concrete payment have a durability, but with respect to the economic also we are being considered, with respect to the economic and also with respect to the maintenance, we are more favor to the bituminous concrete. But while for the past 5 years or 10 years, like we can able to see many rigid payment has been constructed in North India. So that also have also shows a very good results of it.
The expansion joints in those type of payments, sir.
Yes, ma'am. Actually, that is the problem. Actually, that what I mentioned. That repairing of it takes is more. It is more tedious as compared to maintenance of the bitterness. So, if one joint is there is a problem. It is a very joint failure is there. So we have to replace the entire that panel. So that if that joint is over, that there won't be any load to load transfer between the one panel to another. So that sort of difficulties, not difficulty, that sort of challenges also we are facing in order to go with the concrete payment. So there the maintenance is very crucial as far as the flexible is concerned.
So one more question, sir. Like you have mentioned
Yes, ma'am.
What is that? I forgot the name. So all those
Yeah,
things, is it implemented in any project in southern part of India?
no, ma'am. Actually, in southern part of India, I think it is not, as of my knowledge is concerned. But very recently, only in Nagpur, like in Nagpur NH, they have started it, and they are into like process, like how it works. They have like how, because with respect to the region, also it is differs actually. So that also they have implemented for only 1 kilometer long. So after their performance evaluation, it can be applied to other locations. So as of now, implementation in southern India is, I am doubtful, madam.
Because now we are talking about the zero footprint.
Yes, yes,
To my knowledge, the infrastructure development is going to create lot of carbon emissions. So we as
yes, exactly.
engineers, we are responsible to reduce the
Yes,
carbon
exactly.
footprint. So I think whatever materials you have suggested today, I think it has to be implemented. Then only we will be
Yes,
able
yes,
to see a good result in the near future. Right.
yes, ma'am,
Thank you for
exactly.
that wonderful presentation, sir. It was really useful and very insightful also, sir. Thank you so much, sir.
Thank you, ma'am. Thank you.
Any other questions? Ma'am, shall we conclude, ma'am?
Yes, sir.
Uh, Thank you so much, Jagan, for the informative and inspiring session. Now it is my duty and privilege to propose the vote of thanks for today's generic talk series 32 on sustainable innovations in payment materials and design. First and foremost, I extend my heartfelt gratitude to our chief guest, Mr. Jegan Bharath Kumar, scientist, National Transportation Planning and Research Center, NATPAC, Trivandrum, for accepting our invitation and delivering such an insightful and inspiring lecture. Jagan, your detailed explanation about the innovative research at NATPAC, the advanced facilities available, and your clear presentation on sustainable payment materials and design have truly enriched our knowledge and motivated our students. Thank you. I express my
Thank you.
sincere thanks to our honorable chairman, sir, respected vice chairman, sir, and the members of the management for their constant support and encouragement in organizing such knowledge sharing sessions. A special vote of thanks to our principal, sir, for his continuous guidance and motivation that make events like this possible. My sincere appreciation goes to our head of the Department of Civil Engineering, Dr. Randall Madam, for the encouragement and coordination in conducting this event successfully. I also thank all our faculty members for this cooperation and efforts in making this program a success. And to our dear students for your enthusiastic participation and attentive involvement throughout the session. Once again, I thank everyone who contributed to making this program a meaningful and memorable one. Thank you all.
Thank you.
Thank you.
Thank you, sir. Thank you.
Thank you, madam. Thank you all. Thank you all for the patience, and thank you for inviting me.
Thank you. Thank you.